Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Pink Booklet, Practice Test 3, specifically Unit 39, questions 109 to 110. So we've hit the end of the road, last question in the exam, and the good thing is a lot of the prerequisite knowledge we've kind of covered in Unit 3, so questions 8 to 10, where we use the Henderson-Hasselbalch equation. I guess it's a lot. I wouldn't say it's easier, but over here you don't have to have a background knowledge in acid-base chemistry. You just need to know how to substitute equations and work with logarithms. And it would help if you understand as well that P represents negative log 10, and you've probably seen that with examples such as pH, POH, the pKa, pKb, and pKw. So just quickly, they do give us the equilibrium constants, or the acid dissociation constant for Ka. You've got Kb, so the equilibrium constant for a base. You've got Kw, which is the self-ionization of water, and they do give you their formulae. Now, when we look at question 109, we see that obviously question 109 and 110, you need to use the answer from 109 to answer 110. So if you can actually solve 109, you're going to put yourself in a good position to solve 110. So let's take a look at 109. It says, which of the following shows the relationship between the equilibrium constant for base and the hydronium ion concentration? So when we take a look at the options A, B, C, D, we see that there's a Kw in there in the answers. So Kb equals, say, Kw something. So we see the Kw is in there, but the hydroxyl ion concentration is missing. So therefore, if we take a look at the formula that's presented in the stimulus, we've got Kw equals hydronium ion concentration multiplied by the hydroxide ion concentration. How about we just solve it for the hydroxide ion concentration? So therefore, we can just represent this formula as hydroxide ion concentration equals, so just divide this by hydronium ion concentration, divide this by hydronium ion concentration. We're going to be left with Kw over H3O plus, and that's what we end up with. So all we have to do now is just substitute the what we solved for the hydroxide ion concentration into the equilibrium constant for the base. So that means, therefore, it's going to be Kb equals, so substitute, so we've got BH plus, and over here we're going to have our B, and now we're going to substitute our OH hydroxide ion, which we had here before, so it's just going to be Kw over hydronium ion concentration. So therefore our answer has to be, if we take a look at the options, A says Kb, so we've got at the top, at the bottom, there we go. So our answer is A. Straight away, you know the answer has to be A. So just by substituting the values into the equation or the formulae, we get our answer. So it's important to note that the reason why ACER did this was because they wanted you to work your way towards 110, the final, I guess, boss in this exam, to finish off the exam. So if you got this answer, you can work your way through now to 110. So let's have a look now at 110, the final question in the exam. And I might actually use a whiteboard here because it's going to require a lot of substitutions and using logarithms. So what I might do is I might get my whiteboard, but take a look at the exam paper. So it gives you, so we need to look at question 109, answer A. So we're going to use that to substitute our values in. And we're going to make sure we take note that recall negative P, so P, represents negative log 10. So what I'll do is I'll just, I'll go mode here. I'll just get my toolbar and I'll just open up the whiteboard. Okay, great. So let's just write out our known. So Kb. So our Kb, remember from 109, is going to be Kw BH plus over our hydronium ion concentration times our base. So that's what we know. Now, the options, if we take a look at the options that are provided for the answer, so which one represents PKB, we can see that what they done was, so we're going to have a pKw, a pH, and the negative log 10, the base of hydrogen ions over the base. So obviously the acid over the base. So we can represent that. So remember, Kb. So to make that into pKb, we have to add a negative log 10. So what we can do is, up here, we can go, move you across here, negative log Kb. So that's going to make it now pKb. And we just have to negative log this side. Negative log our Kw BH over our hydronium ion concentration B. So that's what we're going to end up with. Now take a look at the options available for 110, A, B, C, D. Let's try to represent it that way. It's the easiest way to represent the equation. So we're going to end up with pKb equals, so remember, negative log, this is going to come out, so that's going to be this minus this minus this. So it's going to be negative log Kw minus log 1 over hydronium ion concentration. And then because we can see in the equation, they've just said negative log 10 BH plus over B, so we can just leave it that way as well. So negative log 10 BH plus over B. So we're almost there. So we've got this now. So this will be our pKw. So that's going to look like this. So this will just be our pKw. So we can probably just write here pKw. So now this is what we're left with. pKb equals pKw negative log 1 over hydronium ion concentration, negative log 10 BH plus B. So we can automatically cross out now C and D. So C and D are incorrect. So it's going to be A or B. Now, are we going to have a plus pH or a negative pH? That's what we have to figure out. So we can rewrite this as, 1 over hydronium ion concentration is the same as just saying hydronium ion concentration negative 1. So we can just rewrite it as pKb equals pKw negative log our hydronium ion concentration minus 1 negative log 10 of this. So that's how we can rewrite it. And we know that if we're going to negative log the inverse, it's going to be a positive. So it's going to end up as pKw plus log hydronium ion concentration minus this section here. So what we're going to have here is, well, this is what's going to confuse students. So they're going to think, oh, plus log hydronium concentration, it's going to be plus pH. That's wrong. Remember, negative log hydronium ion concentration equals pH. Therefore, if it's plus log hydronium ion concentration, it has to be negative pH. Because negative, okay, is what our answer is, because it's plus. So remember, this is what's going to be pH, and then we add the negative in front of it. So that's why the answer is going to be, well, pKb equals pKw negative pH negative log 10 BH plus over B. So that's our answer. I think the trick that ACER employed here was a lot of students would see the plus log hydronium ion concentration and they'd say, well, it's going to be plus pH. But remember, pH is negative log hydronium ion concentration. So the quickest way to obviously turn it to make it correctly with the uh, the sign is to just add the negative in front of it, because a negative makes a positive value. So that's going to make a positive log. So I might as well duck out of here now. I'll get back into ghost mode because I'll clear my screen. Oh, no, I'll leave the screen. So you can see therefore that the answer for 110 has to be B. So I might clear the screen now actually. That was a lot to take in. I think it's important to note, one, how do you substitute equations and formulae and play around with the substitutions. Two, how to work with logarithms. And three, don't get tricked by the signs, so positive, negative. I mean, the trick here was just to note that minus log 10 is P. So that's the key. That's where they were tricking students. And I mean, if you could substitute the values, and if you did have a background in acid-base chemistry and Henderson-Hasselbalch equations, you could have got the answer. So it just required some deductive reasoning and just some follow through. But look, if you're still having difficulty with this unit and you'd like more information, or you can, I guess, post your queries or comments in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.